What's going on, McKinley?
Nothing.
How'd your week go?
Good.
Bored already or no?
I'm bored.
Me too. Me too. Glad it's Friday. How'd the test go? I haven't looked at it yet.
I think it went well.
Good. Should be an easy A, right?
Yes, an easy A.
Good deal. Get started in about a minute from now.
So it's every Friday schedule when we're on Zoom?
Yeah.
All right.
Ben looks to be having internet issues.
Hello.
Hey, Ben.
How are you?
Not bad.
Hey, Ben, you know the best source to get all your needs at?
No, what is that?
Costco.
Wikipedia.
Why Costco?
I said Wikipedia, but Costco as well.
How much snow are we going to get this weekend?
Probably 3 feet, maybe
3
4.
feet? That would be the end of the world.
No.
We had 3 feet, people would starve in Colorado.
How about 3 inches?
I think that's probably more likely what we'll get. They are calling for 2 feet between us and, say, Fort Collins, somewhere like in the Denver area, some places. So those people are going to get hard hit. 2 feet is no joke. That's a pretty big snowstorm.
All right, I am back.
Are you and your brother
Whoa.
at Miss Kittle's house?
No,
Was your brother at Miss Kittle's house?
no, my brother's at school right now.
Oh, he must have been in Miss Kittle's room. That's where he was. No, Miss Kittle sent me an email the other day, and I was thinking that he was at her house, but now it makes sense because he's in 6th grade. They're not on quarantine. Makes sense. All right. Okay, it looks like you two are the only ones showing up live. We'll get started here. It's a pretty quick class. It shouldn't take longer than 15, 20 minutes. We all took our test. I haven't even looked at them yet because every single one of my classes had a test. So I graded all the other ones, and I'm saving your guys' until tomorrow. So I'll have it graded probably before noon tomorrow. I got to have all the grades in by, say, Monday because quarter ends today. But yeah, hopefully there were no surprises. We're going to start chapter 11. Chapter 11 is your standard one that you kind of would think that geometry classes would be about. It's shapes and area and volume. But we're going to get, obviously we've done the easy ones in pre-algebra. So we're going to do the more challenging ones. And we will prove, with exception of the circle and the pyramid, we will prove all the where the formulas come from. But to start this off, we do another one of those algebra reviews. This one's a pretty simple one. We do an algebra review because we will be using some of the techniques that we'll do today in this chapter. So without further ado,
What's the homework though? Is there homework?
There is. It'll be at the end.
Okay.
On the short classes, I don't put the homework at the start. That way I ensure at least you pay attention. All right, so pretty easy for you compared to the other ones. You've heard me use the word plug and chug before. Plug and chug is just it's basically the evaluation procedure where I give you either an equation or an expression, you plug in numbers, you chug through the calculation. This process, once again, is called evaluating. You've seen this for at least 3 years. That's where, as I said before, you replace the values with given numbers. So I'll give you the numbers to use. And then you use PEMDAS, GEMDAS to simplify the expression or the equation. Quick example, here's a variable expression, 2x plus 3y. I will have to tell you what the values to use for x and y. So they'll have a statement, for instance, let x be 4, let y be 5. You guys have done this plenty of times. We plug in the values. Remember to use parentheses, especially when there's negatives involved, so you don't make a silly mistake. And then you just follow PEMDAS, right? Multiplication comes before addition. So 2 times 4 is 8. 3 times 5 is 15. So we get the answer 23. Now, you guys are experts at this. I don't need to teach you how to evaluate at this point, but I will tell you this. The ones for homework, they're slightly more challenging than this. And you'll see when you actually try to do them. A couple will be like this, but many of them will be a bit more challenging. Why are we doing this? Well, we're really doing this because this entire chapter deals with area, surface area, and volume. And we will be calculating those three things. And for those three things, we get formulas. And the definition of a formula is an equation that states a rule about a relationship. So, I mean, here's a classic one in science. Ben, are you familiar with this one?
Looks kind of familiar, but I can't remember it.
Kinley, do you know what the F stands for?
Oh wait,
Force.
it's force,
So force equals what?
Mass.
mass,
Time,
and
Good job, both of you.
acceleration.
Right. 2 brains are better than 1, apparently. Okay, yeah. If you remember, you probably learned it in science, is that force is measured in a unit called newtons. Okay, now we're just adding extra stuff, not part of the lesson. Newtons are a measurement of force, and well, if force is equal to mass times acceleration, here's one example. Mass can be measured in kilograms. It could also be measured in grams. Acceleration is a measurement of distance, so meters over time, right? Over velocity, basically. So over seconds squared. So when you actually calculate force in newtons, what you're really doing is a kilogram meter per second squared. Why second squared? Because remember, velocity is the change in distance. Velocity is equal to displacement, or how far you move over time. So distance divided by time. And then acceleration is the change of velocity over time. So it's basically this divided by another t, and that's where you get distance over time squared. And if you're measuring distance in meters and time in seconds, then that's where this comes from. So there's your trivia for today for that one formula. But the point I'm trying to make in all this is that formulas, they state a rule. The rule is you take mass and you multiply it by acceleration, and that tells you how many newtons. If your mass is measured in kilograms, your acceleration is measured in meters per second squared. And that's the relationship. The relationship is that, well, then you multiply the two together. Okay, cool. If you remember the previous one I just did for evaluation, it was 2x plus 2y. Well, where did that come from? Well, that's the perimeter of a parallelogram, or even a rectangle for that matter, because on a parallelogram, opposite sides are congruent. We've already had that theorem. Therefore, if I were to calculate the perimeter, it would be 2x's plus 2y. This one isn't that particular one. I'm not sure why I have a 3 there. Let me change that. It should be a 2y, not a 3y. Okay, that's better. 2x plus 2y, and well, there's your formula for calculating the perimeter of a parallelogram. All right, cool. So there's our formulas. What we're going to be doing today is we're going to be given formulas, and we'll be giving some measurements. Sometimes they will literally give you literally give you numbers to plug in. Sometimes, they're going to give you variables. But regardless of whether they give you numbers or variables, it's still the same thing. You plug in what you're given and you chug through the calculation. Now, we have not done one where instead of giving a number for the variable x, I gave you another variable for the variable x. Let's see what that looks like. So we are in geometry, so the numbers that we plug in won't be as friendly as they were in pre-algebra and algebra 1. For instance, 12 is friendly, but 6 root 3 isn't all that friendly. Anybody recognize this formula? 1/2 BH?
Polygon?
What kind of polygon?
That type of polygon.
Exactly. That is the formula for area of a?
Hexagon.
Nope, we will learn that one.
Oh wait, isn't it just the cube?
1/2 BH? Times height divided by 2.
Triangle.
That is a triangle. All right. So
I was sitting over here going like, just please say triangle.
So apparently we're going to have to go over a few of these. Yeah, that's the formula for area of a triangle. So just plug in the variables. Let's see. We are told that B is the number 2. So for B, we plug in, I'm sorry, 2, I said meant 12. And for H, ooh, ugly, 6 root 3. So this one's slightly ugly, not impossible. All we do is write what we're given. And then it's kind of your choice of how to simplify this. So McKinley, what are you thinking? How are you going to simplify this?
Well, first I'm gonna do 6 times root 3, but no, that
Well, we
doesn't.
don't know that. That's just 6 root 3.
So just half times 12.
Well, that would be 6.
So 6, then 6 times 6 root 3, which
Would
gives
be
you
what?
your answer.
Which would be what?
6 times 6 root.
We're not doing it on a calculator.
No,
It would be 36 root
62.
3.
Like I'm saying, we're not gonna mess with the square root of 3. It's just the square root of 3.
Okay,
If
so
it's a perfect square, then we'll do something with it, or if we can factor out something, we will. But in this case, we can't. So what's the answer?
36 root 3.
36 root 3. Now, here's the long way of doing it, right? If we made them all fractions, right, and then multiply straight across, make that a fraction, make that a fraction. 1 times 12 times 6, 72. 2 times 1 times 1 is 2. But like McKinley said, you could have done 12 divided by 2 is 6. 6 times 6, 36. So 36 root 3. All right. And there's choices, there's probably easier choices and harder choices, but as long as you do the math right, we'll be okay. All right, here are actually 2 problems right here. McKinley, what do you want? The one on the left or the one on the right?
I'll take left.
All right, tell me what to do.
So first you do 2 times 6, which gets you 12. Then you do.
How about we plug in the numbers first?
Oh, okay. So for both x's you put -2.
Okay.
And then y you put 6.
All right.
So,
why did I put parentheses?
because it told us to.
Doesn't tell you to, but remember, if we didn't put parentheses, it'd be a 26, not a 2 times 6. And occasionally you can get problems with those negatives if you don't put parentheses. Okay, the numbers are plugged in. Now what?
All right, so 2 times 6 equals 12.
Okay.
Then you do -2 minus 3, which you do -5.
Okay.
And then you do 12 plus -2, which gets you, I think 10. Yeah,
That's
10
right.
over -5. All right,
Good way
then,
around.
then you can simplify it to, I guess, -1. No, wait, +1.
Because a
No.
negative divided by a positive is a positive.
No, it's a negative. Yes, -1.
So negative what?
1.
So the answer is -1?
Yes. Oh wait, no, it's some fraction.
What would be the fraction?
No, not fraction, decimal number with the negative.
So what would be the decimal or the fraction? Either one.
Oh,
Look at the numbers.
oh, it would just be 5, -5. Oh wait, -0.0, -0.5.
How about -0.5?
What?
Which is -0.5. I'm not arguing that, but I'm saying just reduce the fraction. 5 goes into 5 and 10, 1 and 2 times.
Oh,
Yes?
okay, I see what I did wrong.
Okay. Ben, you got the one on the right. Tell me what to do.
All right. Sorry, I was putting the cap back on my pen. So what we would do here is, well, first we have to replace the variables a and b. So now we have 2 root 3 times parentheses 2 root 3 plus 4 root 3. So that's the
Okay.
first thing we would do. We would write it all out. The second thing we'd do is we'd add the stuff in the parentheses. Thankfully, since they are both root 3, this shouldn't be relatively difficult.
Well said. Keep going.
So now we've got that, and then it's,
Well, what would you get when you added?
6 root 3.
Now,
Now we
McKinley, if instead of this saying 2 root 3 right here, if it said 2 root 2, could you add these two together?
I think so.
Ben?
No, they have to be the same.
They have
root
to be the
value.
same. So the reason why Ben was saying you can add these two together is because they both say root 3. But if one of them said root 2 and the other one said root 3, you could not add them together. But we can add them together. He said that would give us 6 root 3. McKinley, do you see
And
where I
now,
got 6 from? McKinley?
I've been muted. It's the 2 plus 4, which gets you 6.
There you
So,
go. All right, keep talking, Ben.
and now we just have to multiply the two together, and this is also easy because, well, they both have root 3. And even though it's different rules, kind of, it's similar to the same thing.
Now remember, you can multiply different roots together. It doesn't.
Yeah, I know. But so in this case, the final answer would be 12 root 9.
Okay, so 12 root 9, but we know the square root of 9.
So then it's just 3. So then we take, yeah.
All right. There's another way of doing this one. I like the way you did it, Ben. There's another way. We could have used the distributive property. All right.
Boo.
2 root 3 times 2 root 3 would be 4 root 9 plus 2 root 3 times 4 root 3 would be 8 root 9. And what's 4 root 9 plus 8 root 9?
12 root 9.
Yeah, that's what I got right here. So either way works. I chose the way you did it as well too, Ben. All right. I don't think it's any easier, but maybe so because we don't write so many square root symbols. All right, cool. So, I mean, remember this was on evaluate formulas. So there's going to be some that are not very friendly or pretty. So these are ones you probably haven't seen an answer like this before. The procedure is still the same, but the answers or the question itself is a little strange. So this is even a little bit strange to read. So it says, use the information to rewrite each expression. So first off, you got to see where the expression is. So here's the expression, capital BH. Do either one of you remember that formula?
That's just
yeah.
That's just basically a square, not a square, rectangle.
No, that would be little bh. Capital BH is actually volume of a prism or a cylinder. And we never actually used that one in pre-algebra because we decided that that was just way too, didn't give us enough information. So instead of using capital BH for prisms, we came up with an individual formula for a rectangular prism, triangular prism, and a cylinder. But all three of them had exactly the same formula, capital BH. B stands for the base area in this case. All right, so I lost my mouse here. Come here, mouse, where are you? There you are. Okay, so to plug in the values, so let's see, what does it tell us to do? It says, if you see the letter B, I'm going to write this sucker right here. Now, this is a formula that we will see in this chapter. I'm not going to spoil it for you and tell you what it is, but we'll see this. So all they're asking to really do is replace capital letter B with 1/2 RS. So we do that. So let's see, we replace capital letter B with 1/2 RS. And then we attach an H to it. And well, we just plugged in the values. Now notice, with exception of a half, we're plugging in variables for another variable. So this one isn't satisfying in the sense of now we can do some math, like now we can plug and chug, or we can chug through some calculations. But the reality is sometimes, you'll see it here in another example or two, is that you will get some variables that you can combine together. In this case, no. I mean, that's just basically the answer, 1/2 RSH, okay? All right, and we'll see this one in this chapter, but just not right now. All right, once again, McKinley, what do you want, left or right?
I go right this time.
All right, Ben, you
then
got
I'll
left.
do left. All right. So the problem is A times parentheses A plus B and parentheses times 2. So since we see here that if there is an A plus a B, we replace it with an X. So if we look in the problem, we see that there is an A plus B. So first thing to do, we must replace the value. So we get A times X times 2.
And what Ben just said there, McKinley, is if you see an A plus B, we were told that we can replace it. If you see an A plus B, we can replace it with an X. Ben saw an A plus B, so he replaced it with an X. All right, is there anything else you can do, Ben?
No, not really.
No, not really.
Oh, you can
by
make
the
up
way,
numbers.
well, I will accept this as the answer. Now, the book would say if you have a coefficient, always write the coefficient first. But the reality is that that answer right there is no different than the previous one. So I wouldn't mark it wrong no matter which one you wrote, but you would have to do that substitution. Okay, good job, Ben.
Wouldn't it be smarter to have it order-wise, even though it is multiplication, you can arrange them differently?
I mean,
It
the
would-
only reason, and it comes from that previous one that you did, the only reason that we put the coefficient first rather than middle or the end is because, well, what if there was another AX like plus 3AX? Then you could add them together, right? And so we would like our coefficients to be the first numbers, since that's what we would be looking for to add the two together. And that's literally the only reason we write coefficient first. It's just easier for us if there's more math to do. In this case, there's nothing else to do. So, I mean, I would argue that we didn't really accomplish anything by putting the coefficient first. It's just, it's not called standard form, but if it was, we would put it first. All right, McKinley, you're up.
All right. Well, you see, first you take NS, and then that equals P.
So if
So
I
you
see an
do-
NS, I can write a P. Do you see an NS?
Yeah, I see NS.
Okay, I do too. So now notice the order is slightly weird. It's N times a half, or I should N times the quantity, 1/2 SA. But remember, multiplication is commutative. We can write these in any order we want. So we could change that formula right there to 1/2 times NS8,
And
only
then
because, keep going,
you just put a P where that is, and you're done.
and you got it right. This is another formula that we will use this year, and it answers the question that McKinley brought up about, I don't know, 4 minutes ago. He just didn't realize it, that this would be one of the formulas. 1/2 PA actually will answer McKinley's question a while ago. And I will hold that for a couple days until we get to it. And then I'll remind you again, hey, this is what McKinley said during the algebra review. Okay.
That's if anybody watches this.
Well, they're going to watch it. Everybody watches it. They just decide not to be live today.
Yeah.
All right. You got your books handy?
Yep.
Here's your
No.
homework, and I will allow you to pick one or two in remaining time, and we'll do it together. So on page 419, McKinley,
Gosh,
go ahead and pick one.
If there were more people, we could have gotten out, what, 4 or 5 of them?
Let me see. 15 looks a little complicated.
All right, let's try 15. So let me go back. 15 says the following. 15 says 1/2. This kind of looks like what we just did. 1/2 times parentheses. Oh, no, well, there's an H there. 1/2 H times parentheses A plus B. And it says when H is equal to 3 and A is equal to 3√2, and this one's got a third one, and B is equal to 7√2. All right, this is your problem, McKinley.
Okay. So you put H with 1/2, but I already made it a fraction to 3 ones.
Then
Then
you
you
one
put,
more time.
oh, so you put 3 next to 1/2 where the H
That's
is.
better said. Okay, so that I don't know why I wrote 1/3.
Well, that's the
1/2,
next step I did, but
yeah,
yes.
times 3. Keep going.
And then you put then you put parentheses A, which is 3 and 3√2,
It is.
and then 7√2 time plus 7√2. Then from there you do 3 plus 7, which is 10
So 1/2
√2. Oh,
times 3, and you said that turns into 7√2. Okay.
no, it turns into 10√2.
Oops,
Not 7.
my bad. Okay.
All right, then you turn 3 into a fraction, which gets you 3/2.
So we have 3/2 times 10√2.
Then you do 3/2 times 10/1.
Okay.
And then the 2 and 10 cancel out each other, or no, wait, they cancel each other, which you get 5 and 1. So you just get 15 root 2.
Boom. Very well done. And that is the answer. 15 root 2. All right, Ben, pick one, and then we'll call it a day.
All right, let's just do number 1.
No, eins. Really? Really?
I mean, fine. Let's do a more complicated one.
You can do one if you
All
want.
right, number 2. That one
All
looks
right.
pretty complicated.
Okay, so
Oh,
number
that's
2,
scary.
we got the square root of a squared. This looks like Pythagorean theorem, right? Plus b squared. By the way, this is
Oh, I see what I did wrong.
what C is. So basically, we're solving for the hypotenuse of a triangle. And we're told that A is 15 and B is 20.
All right, so the first thing we would
Right
do here.
triangle with side lengths of 20 and 15, and we are solving for this value, C. And it would be that formula right there. All right.
All
keep
right,
going.
so the first thing we would do is we replace A with 15 and B with 20.
You know those
Next
perfect
thing,
squares off the top of your head?
yeah, I actually do know them. 15 to the second power is
Are you consulting your girlfriend?
no,
All right.
that's a different one. That one died, literally. Yeah, I
That really
broke it.
died?
I broke it. What?
I have
No.
never heard of anyone breaking a graphing calculator, ever.
What if you smash it with the hammer after fury and hatred for it?
Well, it was
All
supposed to be-
all the insults that are gathered along
What
with
did your
it.
calculator ever do to you?
Nothing. It's what you guys did to me.
All right.
So you're blaming society like in that Joker movie.
So now you have a new girlfriend. What's her name?
No, it's not like that.
Okay.
This one's a
15 squared.
robot. 15 square is 225.
That is right. You can do 20 squared in your head, right?
Yeah. 460.
What?
Yeah.
Where would
20
the 60 come from?
My head said 60 and I put it in front of 400.
No, it's 400. All right, add those two together, we would get what?
625.
Wait,
I know that one.
Well, notice we'll do without a count. Notice 25 would go into this, right? So let's see. That would be 25 times what? 20 times 4 is 100. We've got 6 of them, right? So that would be 4 times 6 is 24 plus one more. That's 25 times 25, right?
Yeah, so it's 25.
Yeah, so it's 25. And that is the answer.
Hey.
Boom. There we go. 1 week down, 1 week to go, and next week is only 4 days as well. Any questions on anything we did today?
No, all simple.
I agree. The next chapter, I guess it's kind of fun, right? It's definitely familiar. It's got a lot of theorems, but they're mostly, ones that are easily recognizable. So I will leave it there. Like I said, I'll have your test graded tomorrow. And if you have any questions, though, on the homework tonight, just send me a chat or email, and I'll be happy to answer it. You guys have a wonderful weekend, and be ready to shovel some snow.
Goodbye. Have a nice day.
Goodbye.
All right, see ya.